Hey y'all, this is Mrs. Tran-Bloom. We are now in Unit 4. Just to remind you guys that Unit 4, we will not have an exam for this unit, but all of its content will be on your final exam, okay? So let's start with 2.6. So this one, it's sort of a little bit of each chapter. So we have one section from 2.6, we have one section from 3.4, and 3 sections from 11 and just one more from 12.1. Now 2.6 and 3.4 are all applications. So you guys make sure you guys pay attention, careful attention to each example, all right? Example A string of 12 inches long is to be cut into 2 pieces. So you have 12 inches long. It's to be cut into 2 pieces, and we don't know where we're cutting, okay? One piece will be shaped as a square, so we are going to draw a square. A square means every single side is exactly the same, and the other will be shaped as a circle. And again, we don't know how or where we're cutting the string. Example 1A, express the total area, is now called A, enclosed by the pieces of string as a function of length x of a side of the square. So every single variable, make sure you understand what it is assigned to. So each x is a side of the square. So as you can see right now, this perimeter is now 4 x's, right? Because perimeter is adding up the side. So currently, we're using 4 x's for the perimeter. So that means the perimeter of the circle, well, in circle, we don't really call it a perimeter, we call it a circumference, right? The circumference of the circle is 2 pi r, but we have already used 4x for the square. We have 12 inches total, okay? We have used 4x already for the square. So we take it away from 12 to give us the perimeter of the circle. Okay, remember, we were given 12 inches to begin with. So now it says, okay, write an area of both shapes. So area of both equals the area of the circle plus area of the square, and it wants it in terms of x. So area in terms of x would be area of the square first. Let's do the square is x times x, which is x squared. Area of a circle is pi r squared, but it does not want r in it. Remember, we want it only in terms of x, and x means one side of the square. So we have to get rid of this r and then chuck in only variables of x. Well, I do have an equation with x and r over here. So what we're going to do is solve for r, okay? So let's do it. We're going to solve for r by dividing each and every term by 2 pi. Just like that. So that will give us r equals 12 divided by 2. That's going to be 6 over pi. So this is 6 over pi. 4x divided by 2, that will give us 2x over pi. Now you can also write r equals 6 minus 2x over pi, which is what I'm going to use. So back to your area formula. We are going to put in 6 minus 2x over pi, and it's r squared, so it's now square plus x squared. So now as you can see, I'm going to try to reduce this a little bit, okay, because you have pi on top and bottom. So this is a pi here. This is 6 minus 2x quantity square. I'm also going to write pi square. Remember, when you have a quantity square, you can break it up into 2 squares, just like top and bottom. So this will allow me to cancel 1 pi on the top and 1 pi on the bottom. So your final area of both shapes in terms of x. And remember, do you know what x represent? I hope you do, because if you don't, you're going to be in trouble because you don't know what you're looking for if you don't know what each variable represents, right? X represents one side of the square. A represents what? The total area of both shapes. So now we have the formula to find the total area of both shapes. B, what is the domain of A? Okay, so now it wants to know the domain of A. Well, what on earth is A? What A are they talking about? Ah, they're talking about this A. Okay, remember, anytime that you are reading a question, make sure you know what each variable represents. So it said, okay, well, you have an equation. Now tell me what the domain is. Well, would you guys agree? The domain means what input, what X has to be. Okay, I hope you do. Now, if X represents one length of the square, would you agree? Okay, would you agree if X represents one length of square, would you agree it has to be then bigger than 0? Because you can't make a square that's a negative length, and you can't make a square if it's a 0 length, so it has to be bigger than 0. Now, what is the biggest length? What is the biggest length of X? What is the biggest value of X? Okay, then now we got to go back to your string. If you have a string of 12 inches long and do you have a square, that means each, remember, this is 4 X's, right? So you divide into 4. So the most this could be would be 3. Now, it can't be exactly 3. That's why I'm not using less than or equal to. It can only be 2.99999, right? Up to 3. Then whatever's left over could be used for the circle. So what if you have 2.999 like this, right, as X? Well, that means you still have a little bit left for the circle. Yes, that's a very small amount of string to make the entire circle. And so normally we can't do it by hand, but that does not mean it's not doable, right? Any small amount that's left, it's still feasible to make a circle. But sometimes we can't just do it by hand. That's why we use machine to do a lot of stuff. So the domain of A, and remember, A is the area of both shapes. The domain is looking for the values of what X could be, what the input could be. So X, since this one says it's one side of the square, it has to be positive numbers only. And because you have a string of a total 12 inches, then that means there's 4 sides. So the most that it could be is up to 3, but not including 3 because we still need to leave a little bit left for the circle. C, graph A equals A of X. And again, what on earth is A equals A of X? Okay, so make sure we know, okay, well, that means this equation. So now I'm going to use decimal for this particular example and graph it out. So I'm going to bring up my decimals and enter in your A of X equation, okay? Just like what we have on our paper. So A of X equals 6, as you can see, take away 2x, the quantity of that square, all, and then divided by pi, then plus x squared, the bottom. So now that we have this, as you can see, I have a parabola, okay? Now this parabola, as you can see here, I'm going to go and flip my computer really quick and label the x and y axis for you. So your x-axis is one side of the square. Now the y-axis is total area for both shapes. So you have to understand what each variable represents for whenever you guys are doing an application. And it's looking for the smallest side, right? So all we do is we're going to go in and trace that value. So currently the smallest side that you can have, which again is the x, right? 1.68. So go back and write 1.68. x equals 1.68, and I think the original unit would be inches. Okay. When the area for both shapes to be smallest. Now on the exam, I might also ask you what is the smallest combined area. Then you could also add that on. So this is an addition here, okay? The smallest combined area is, let's go back to decimal and look for the y, 5.041 is 5.041 inches square, since it's an area. Now, just a little recommendation here, guys. Don't be stuck on just the circle or the square. I may add in a triangle. I may add in a rectangle. I may add in whatever shape I want. So try to understand the concept and the steps more than be stuck on the shape. All right.